Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over an introduction to oxidation reduction reactions. So let's get into this. So I'm going to do this in kind of two parts. First, I'm going to go over the oxidation reduction reactions involving the formation of binary ionic compounds, and then we'll look at oxidation reduction reactions involving the formation of molecular compounds. Okay, so the first thing I want to go over before anything else is this mnemonic device that I think will help you remember the difference between oxidation and reduction. So it's really important to keep this in mind. So I have a couple of mnemonic devices, that is, phrases that will help you remember the difference. So the first one is Leo Grr. You could think of this as Leo the lion goes grr, right? So what does Leo Grr stand for? Leo is loss electrons oxidation. So the loss of electrons is oxidation, right? Grr, the lion goes grr, Leo the lion goes grr, stands for gain of electrons is oxidation. So gain electrons is reduction. Did I say oxidation? I meant reduction. So gain of electrons is reduction. So gain electrons reduction, loss electrons or lose electrons oxidation. So Leo Grr. So that's one mnemonic device. A second mnemonic device that I learned all the way back in high school and it still works for me today is oil rig. So oil rig is basically the same idea. So oil oxidation is loss of electrons, and rig is reduction is gain of electrons. So either one of these is perfectly fine to use to help you remember the distinction between oxidation reaction and a reduction reaction. And the two go together. And I'll explain this in just a moment right now. So let's go over a couple of examples of the formation of binary ionic compounds. So not all reactions that create a binary ionic compound is going to involve a redox reaction, but many do, I think. So here are a couple of examples. So here's the overall reaction. I have two atoms of zinc solid reacting with one molecule of oxygen gas to form two formula units of zinc oxide. So what you want to do a lot of times when we're breaking down this reaction is to break it down in what are called its half reactions. It's reduction half reaction and it's oxidation half reaction. And so what we can do here is just look at what is happening to each element in the formation of this ionic compound. So if we look at zinc, we'll take a look at what's happening at zinc. So zinc here is a solid, has no charge on it. It's a neutral element. It's a neutral atom. And then all of a sudden, zinc, in the formation of this ionic compound, in order to balance the charge on oxygen, oxygen has a 2- charge here. Zinc has to have a 2+ charge. So we're going from zinc that is a neutral atom to zinc that is a 2+ charge. The only way that happens is if zinc loses 2 electrons. So here we have the 2 electrons. So zinc goes from solid neutral atom to having a charge, a 2+ charge, and therefore losing 2 electrons. So here we have the two electrons being lost by zinc. Now here we have 2 zinc atoms. So you could write this another way with both the zinc atoms. So to be complete, both of our zinc atoms are going to become ions. So they're both going to have a 2+ charge. And so that means that both of them are going to lose 2 electrons. Therefore, the total number of electrons is 4 electrons. So that's another way you can write it. But the basic equation here is this one here. Now, so what's happening here? Well, we go to our Leo GER or oil rig. So loss of electrons is oxidation. So here, zinc is losing electrons. So this is an oxidation half reaction. So we can identify this. We'll just put this around the equation here. So if I box this one, so here zinc is losing electrons. So this we're going to label oxidation. If we look at the next one, let's look at what's happening to oxygen here. So oxygen, again, we have a neutral element. We have the molecule of oxygen. There's no charge on the oxygen here. And then we go to oxygen in the ionic compound. This is an oxide, so that means that oxygen has a 2- charge here. So we see that here. So if you write this half reaction out, oxygen gains 2 electrons to become an oxide ion with a -2 charge. So the only way that oxygen has a 2 negative charge is if it gains 2 electrons, right? Simple enough. We could also write this in the form of O2, since we actually have O2 molecule, then we have 2 oxygen atoms bonded together. And that means that we're forming 2 oxide ions, so that both of those oxygen atoms in the molecule should join or to add 2 electrons. So since we have 2 atoms here, that means they're both going to gain 2 electrons. That's a total of 4 electrons. And so we're going to end up with 2 ions of oxygen, both with a -2 charge. And so you could write it like this too. So here, if I use a different color, use red on this one. So here is our other half reaction. So what's happening in oxygen? So excuse me. Sorry about that. So here, gain electrons reduction. Gain electrons reduction, or RIG, reduction is the gain of electrons. So here, oxygen is gaining electrons, so this is reduction. Reduction. So it's really important to understand at this point the importance to that both of these half reactions are happening simultaneous during the reaction. How is that? So we have zinc and we have oxygen. We have a metal and non-metal. Metals love to give away electrons. Non-metals love to take the electrons. So zinc is not going to lose electrons unless there's something there to take them. So here, the giving away of the electrons by zinc is resulting in oxidation of the zinc. The zinc is losing electrons. It's giving them away, but zinc is not going to give away electrons to nothing out there. It's got to give them to something. Something's got to be present to take the electrons. So as zinc is losing the electrons, it's giving those electrons away to the oxygen. The oxygen there is to pick them up. So what's happening to the oxygen as they're picking up the electrons? They're gaining the electrons. Reduction. So as zinc is losing the electrons and undergoing oxidation, oxygen is taking those same electrons and undergoing reduction. So this is happening simultaneously. So if I had a $100 bill and I gave you the $100 bill and you grabbed the $100 bill, I am losing $100 at the same time as you are gaining the $100. I am $100 poorer, excuse me, I am $100 poorer as you become $100 richer. So it's the same idea here. So oxidation and reduction are happening simultaneously at the same time. So let's look at our second example. So here I have sodium metal reacting with chlorine gas to form sodium chloride, another binary ionic compound. So again, if we look at what's happening to each element separately, if you look at sodium, sodium is zero charge. It's neutral atoms. I have two neutral atoms of sodium. And then here in the compound, they have a charge, right? I have sodium and chloride. This has a +1 charge. So sodium lost one electron. So I could write that as NaS going to Na plus with one electron being lost. Or because I have two sodiums here, I could write it as two sodium solid, two sodium atoms neutral, becoming two Na plus ions, losing a total of two electrons, one electron each. So again, since sodium is losing electrons, right? Leo lost electrons. Oxidation or oil, here an oil rig, oxidation is loss of electrons. So here the metal is undergoing oxidation, right? Because metals love to lose their electrons, so their tendency is to undergo oxidation. And then if we look at chlorine, chlorine is a neutral molecule, zero charge. But then if we come over here, it's got a -1 charge as part of this ionic compound. So it becomes an ion, a -1 ion. And so we can write that down here. Cl plus 1 electron gives us Cl minus. Or since we have two chlorine atoms bonded together, we could write it as Cl2 plus 2 electrons, right? Because each chlorine atom is going to gain one electron to then form two chloride ions that we have in our compound. So 2 NaCl. So we have two chloride ions. So again, the chlorine is undergoing reduction. So gaining electrons. So this is reduction. And so that, ladies and gentlemen, is an introduction to oxidation-reduction reactions in the formation of binary ionic compounds. Now let's take a look at the formation of molecular compounds. But wait, before I do that, there's one more thing for me to go over that's really important, and it's quite confusing or confuses students quite a bit, and it's understandable. But let me go over this idea of reducing agent and oxidizing agent. So as the name agent implies, an agent is an actor, something that does something, right? When we say a carcinogen or a cancer-causing agent, it's something that causes cancer. It does something to cause cancer. So in the same way, we have to understand reducing agent and oxidizing agent in the same way. So remember what I said regarding reduction and oxidation happening at the same time. So why does oxidation and reduction happen at the same time? It's because here, for example, zinc is giving electrons away and oxygen is taking the electrons. So we have a transaction happening here, right? A transaction. Agents are involved in a transaction. So zinc here is doing what? It's doing something. It's giving the electrons to oxygen. By giving the electrons to oxygen, it is causing oxygens to gain electrons. Well, what is the gaining of electrons? The gaining of electrons is reduction. So if zinc is causing oxygen to become reduced by giving its electrons to oxygen, right? Oxygen is taking the electrons. Therefore, zinc is causing oxygen to be reduced. So it's a reducing agent. Okay, so let me put a box around that. Okay, let me use a different color here. So here, zinc Zinc is a reducing agent. I'll put Ra for reducing agent. So why do we call it reducing agent? Again, it's causing oxygen to become reduced, to undergo reduction. How is it doing that? It's giving its electrons to oxygen. Oxygen is taking the electrons. Okay, so on the flip side, what's happening to oxygen? What's going on from oxygen's perspective here? So oxygen is taking the electrons away from zinc. So it is an actor as well. So it's taking the electrons from zinc. So it's taking them from zinc, right? So it's acting by taking electrons from zinc. So in doing so, it is causing zinc to lose the electrons. So it's taking electrons away, therefore zinc is losing the electrons. And what is loss of electrons? Lose electrons, oxidation, or oxidation is loss of electrons. So oxygen, by taking electrons from zinc, is causing zinc to lose electrons. It's therefore causing zinc to be oxidized, right? So therefore, it is an oxidizing agent. So oxygen in this case, here I'll use green. Oxygen in this case here is the oxidizing agent. Why? Because it's causing zinc to be reduced. So, I'm sorry, causing zinc to be oxidized. So I'm going to put OA here. And so zinc is the reducing agent because it's giving electrons to oxygen, causing oxygen to be reduced, right? But then oxygen is the oxidizing agent because it's taking electrons away from zinc, causing zinc to be oxidized, right? So that's how you figure out oxidizing agent and reducing agent. Now, the other thing I have to say. Oh well, let me go over this, and I'll finish up with my last comment. So here, again, same thing going on here. So we have sodium. Sodium metal is giving the electrons to chlorine. So by giving the electrons to chlorine, it's causing chlorine to be reduced. So then, in this case, Sodium here would be the reducing agent, Ra, reducing agent. And then chlorine, again, in this case, chlorine is taking the electrons away from sodium. So in taking those electrons, by taking those electrons away from sodium, it's causing sodium to lose the electrons. Losing electrons is oxidation. So it's causing sodium to be oxidized. So we call that the oxidizing agent. So in this case, chlorine is the oxidizing agent. Now, there's one really important thing you have to remember when you're distinguishing oxidizing and reducing agent. The agents are always the complete compound or element or molecule that contains what is being reduced or oxidized. What do I mean by that? So you'll notice here, so zinc is the reducing agent, but the reducing agent contains the element that is being oxidized. So the opposite is happening to the agent, or an element that's in the agent, right? So the element is being oxidized or reduced, but the agent is the compound or molecule or whatever the substance is that contains the atom or element that's being oxidized or reduced in it. So here, for example, O2 is a molecule that contains two atoms of oxygen. It's the atom of oxygen. Each atom of oxygen is being reduced by the zinc. But the single atom is not the reducing agent. It's the O2 that's the oxidizing agent in this case. So the oxidizing agent is not the oxygen atom. It's the whole molecule O2 that contains the atoms of oxygen that are being reduced, right? So it's hard to kind of see here, but that's the thing you got to understand. So it's the whole reactant, the whole compound. If it was a compound, then it would be the whole compound. So the atoms themselves are what's being oxidized or reduced, but it is the whole reactant that is the reducing agent or the oxidizing agent. Okay, so I just want to make that clear. So the reducing agent is the sodium, right? And the oxidizing agent is the Cl2, even though it's the chlorine atom. Each of the chlorine atoms are actually reduced, but the whole thing here is the oxidizing agent. So don't mistake the atom for the oxidizing agent. In this case, it is, because that's all we have here is atoms. But here we have a molecule. So the whole molecule is the oxidizing agent. If this was a compound, right? If this was some sort of compound, like say H2O or something like that, then the whole compound would be the oxidizing agent, but it would be containing in itself an atom or an element that's being reduced. Okay, so this will be clear when I do the formation of the molecular compounds. So let's go ahead and get into that. Okay, let's go over the formation of molecular compounds now. So here's an example. We have N2 gas reacting with oxygen gas to form NO gas. And so here we don't have a metal and a nonmetal, we have two nonmetals. And here it's a little bit different in the sense that we don't have a complete transfer of electrons from one thing to the other. When we had a metal and a nonmetal, the metal gave its electrons away, the metal took the electrons, so you had a complete transfer. In this case, since you don't have a metal and nonmetal, you have two nonmetals that both want electrons, they're going to have to share. So here, you have a sharing of electrons to form a covalent bond between the nitrogen and the oxygen. And so when you look at that bond, there is not an equal sharing of the electrons insofar as the oxygen is more electronegative. So if you remember, the more electronegative atom is going to pull those electrons that are in the bond closer towards it. So that's going to give this a partial negative charge. And then therefore nitrogen, because the electrons are being taken away partially from the nitrogen, is going to have a partial positive charge. And so here it's not a complete transfer, but a partial transfer. But the idea of oxidation reduction still works, still applies, because you still have, in some way, partially, the electrons being taken away from nitrogen and partially given to the oxygen. And so here in the covalent bond, you don't have a complete transfer, but a sharing of the electrons, but it's not an equal sharing. The oxygen is going to be taking those electrons more. So again, this is a partial transfer, but the idea is the same. So if we think of it just as a partial transfer, nitrogen is giving the electrons to oxygen partially, but again, using Leo Ger or oil rig, we know that loss of electrons is oxidation. So nitrogen is partially losing electrons, not completely, but partially. So in this case, nitrogen is losing the electrons, so it's undergoing oxidation. So here, oxidized. So N2 is being oxidized because it's partially losing its oxygen. So the not N2, but the nitrogen in N2, the nitrogen atoms are being oxidized. And so that means oxygen Oxygen is gaining the electrons partially. So gain of electrons is reduction. So that means that oxygen is being reduced. So gain of electrons is reduction. So reduced. So oxygen, the oxygen atoms in the oxygen molecule are being reduced. So then what's the oxidizing agent and reducing agent? So remember, that's the whole thing. So since the nitrogen is giving partially its electrons to oxygen, is causing oxygen to be reduced. So nitrogen N2 is the reducing agent. So I'll put that here, Ra, reducing agent. And then since oxygen is taking electrons partially away from nitrogen, it's causing nitrogen to be oxidized. So then, let me use a different color. So then oxygen here is the oxidizing agent. Again, it's the O2 molecule is the oxidizing agent, not the oxygen atom. It's the whole thing. And so therefore, we can talk about reduction, oxidation, even though there's not a complete transfer of electrons. So we can kind of look at here in a summary kind of sense. So here's a summarization. So here the electron is being given from one substance to another. And because it's losing the electrons, it's giving its electron to this substance. So that means that this is the reducing agent because it's giving the electrons to, it's actively giving the electrons to this substance. This substance is taking the electrons away, actively taking the electrons away from this substance. So it is an oxidizing agent. It's causing this substance to be oxidized, but it itself is gaining electrons. Therefore, it is being reduced, or the element that it contains is being reduced. So it's causing this to be oxidized, but it's in the process of becoming reduced at the same time. This is the reducing agent. It's causing this substance to be reduced by giving its electrons to this substance here, but in the process, it's losing the electrons, and therefore it is being oxidized. So the reducing agent is causing the substance to be reduced, but it itself is being oxidized, or at least an element in the reducing agent is being oxidized. And so depending on whether you have a partial or complete oxidation, or complete transfer of electrons, you're going to either get ionic or covalent. So if it's a complete transfer of electrons, then you end up with charges on both of your elements, and you form ions, and therefore you get an ionic bond. And then here, if it's only a partial transfer of electrons, meaning that the electrons are shared between the atoms, then you form a covalent bond. And if there is that unequal sharing of the electrons, you form that polarity. And so this side would be more electronegatives, therefore it has the partial negative charge. This side is less electronegative, it has a partial positive charge. And so you get that covalent bond, but you still get reduction and oxidation happening because you still have a partial transfer of electrons. So in the end, we have to understand oxidation and reduction more broadly. So oxidation we'll understand as the complete or partial loss of electrons, complete if it's ionic, partial if it's covalent, and then reduction would be the complete or partial gain of electrons. Again, complete if it's ionic, partial if it's covalent. So that's it for this video. I hope this was helpful. If this helped you in any way, please like the video, share the video with your friends and family, hit that like button over there. Also, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a question or a problem you want me to help you solve, I would love to do that for you. Thanks for joining me, and have a great day.